Let us analyze a circuit using KCL. This is a circuit with all these elements. In all these branches, what is the current? We have to calculate. For that, we are using KCL. In the question already it is given that branch current I1, that is I1 is equal to 10 ampere, then I2 is equal to 6 ampere, I5 equal to 4 ampere. The question is calculate all other branch currents. For that we are applying KCL. So let us see, KCL is a junction rule applicable for junction. Therefore we are identifying what are the junction. Here it is a junction. Am I right? Junction A. In this junction, how many branches are there? 1, 2, 3. 3 branches are connected together. In this node A, current I1 is entering, current I2 and I4 are leaving. Therefore, applying KCL to the junction A, we can write at A, I1 is equal to, already I1 is given, I1 is equal to 10 ampere, that is also given, I1 is equal to 10 ampere and I2 is equal to 6 ampere, that is also given. Then we can calculate what is I4. I4 is equal to 4 ampere. Now, see another junction B. In this junction, there is also 3 branches. In 3 branches, current I2 is entering to the junction, I3 and I5 are leaving the junction. Therefore, current entering is equal to current leaving, current entering I2 is equal to current leaving I3 plus I5. I3 we don't know, I2 we know 6 ampere, I5 4 ampere. Therefore, I3 equal to I2 minus I5, that is 6 minus 4 equal to 2 ampere. Then see at junction C. At junction C also 3 branches, I5 entering, I6 entering, but I7 is leaving. Therefore, I5 plus I6 equal to I7. I6 equal to I7 minus I5. I6 equal to I7 minus I5. What is I7? I7 is equal to I1. I7 is equal to I1. Therefore, I1 is equal to 10 ampere. So, I7 is also 10 ampere. 10. Then I5 is equal to 4. Then 10 minus 4 equal to 6 ampere. Now, we calculated all branch currents using KCL. Now see, what is Kirchhoff's voltage law? Kirchhoff's second law or Kirchhoff's voltage law. KVL is also called as loop rule or mesh rule because KVL is applicable for a mesh or a loop or it is applicable for a closed path. This law related with the conservation of energy. That is, energy supplied by an element is always received by another element. Okay, here in the circuit there are 2 active elements, voltage source V1 and voltage source V2. These 2 elements will supply energy. There should always be some other elements for receiving the energy supplied by the active elements. Now in the circuit there are 2 resistors. These resistors receive or they consume energy from the sources. Therefore, as per KVL, the supplied EMF is equal to drop in the elements or algebraic sum of voltage in a loop is equal to 0. Now let us see. What is the voltage of the source V1? Voltage of the source V2. Voltage drop in this element. This is a resistor. Therefore, voltage drop V is equal to IR1. This is also a resistor. Voltage drop in this element is equal to IR2. And let us see. We are are considering this loop. This is a loop, right? We are considering this loop. I am starting from this point. I am coming, okay. This voltage means, if this source has voltage V1, means this terminal will have a zero potential and this terminal will have a positive potential V1. So when I traced from here to here, the voltage level increased from zero potential to potential V1. Here the potential is V1. Okay. Again, the potential of this source is V2 means the potential difference between this point is V2. But our potential at this point is V1. Then the potential at this point is V1 plus V2. Here V1, therefore here V1 plus V2. The voltage increased. But when current comes to this element, what happens? There will be a drop in this element. The drop in this element means the current entering point of the resistor is marked as positive and current leaving point is marked as negative. So when we traverse this circuit, when we comes from here to here, there is a drop. So what will happen? When we traced from here to here, the voltage V1 plus V2 minus IR1, because here voltage reduced. Again here also voltage reduced because current is entering to this point. When current entering this point, that point is marked as plus and current leaving point is marked as negative. Therefore, there is a drop in this resistor. So, when we traversed from here to here, again another drop, that is IR2. What is KVL? KVL, in a loop, the algebraic sum of voltage is equal to 0. That is V1 plus V2 minus IR1 minus IR2 equal to 0. Okay. In another terms, the total voltage or EMF supplied by sources is equal to the algebraic sum of product of current into resistances. That is, supplied EMF or supplied voltage is equal to V1 plus V2. Voltage drop in this element IR1, voltage drop in this element IR2, algebraic sum of voltage drop in the elements, that is IR1 plus IR2. Okay, then KVL is stated using these equations. Okay. In this circuit, you wrote the KVL equation or mesh equation, that is V1 plus V2 minus IR1 minus IR2 equal to 0. Here you taken the branch currents, that is this current I is the branch current. But in this circuit, please see, here branch current is not given, but mesh current or loop current is given. Then you should be very careful while writing the KVL equation. Now see this mesh. I am tracing this mesh. I am starting from here. From here to here, the voltage increased, that is minus plus, then voltage increased. The EMF source value V. Then this current traveling in this, that is in the clockwise direction. In the clockwise direction means in our traveling direction, this current is entering here in this element, and in this element here it is leaving. That is here plus and here minus. So current I1 and resistance R1 drop minus I1 R1. Okay, V minus I1 R1. Then comes another element in the loop, next element in the loop. Next element I marked here plus and here minus. See this current I1 entering here and leaving here. So there will be a drop. Plus minus means voltage drop. Then that should be negative. That is minus I1 R2. Minus I1 R2. But there is another current also through this element. That is current I2. That current I2 is coming like this. That is that current entering here and leaving here. So here plus and here minus. Therefore, the drop due to this current I2 R2. This I2 R2 will be positive because here plus and here minus. So we are traveling from here to here. So it will increase. That is, that current should be entered as plus I2 R2. In general, we can say V minus I1 R1 minus I1 minus I2 into R2. That is, current I1 is coming in this direction, I2 is going upwards. So net current is I1 minus I2 into R2 will give the voltage. Right. So you should be very careful while writing the KVL equation. See whether the current given is branch current or loop currents. Okay.